Top 5 faults, take 1. You're a photovoltaic technician and you're sent to the field to figure out why a certain PV system is not producing the energy it is supposed to produce. Here are 5 electrical issues you can start considering. And I have the presentation here. You can go to the website emesis.com and find out a lot more. Number 1, DC distribution, faults in connectors and cables. Actually, it's a bit surprising because normally when a new technician goes to the field, he is to some extent taught that homogeneous power degradation in the solar panels is the most common fault, because we have this idea that when you install a power plant, then after 20 years, the efficiency of that power plant is just slowly degrading over time. But when we look into it and we go into depth and actually do some investigative work, we see that it is not homogeneous production loss that is the main problem out there. It is, of course, also part of the story, but the most frequently occurring problem out there is actually something that has to do with the DC distribution. So it's faults in cables and connectors. And then the next fault on that list is DC distribution, where you're talking about grounding and isolation faults. And then on a third place, I would rate the light absorber degradation, that is typically presented as the most important thing. But actually we have now the data. That's the difference. In these modern times, we actually have data that shows us very clearly that the DC distribution, cables and connectors is probably the most frequently reported problem area in a photovoltaic system. Number 2, DC distribution, grounding and isolation faults. Probably some of the most interesting studies were done by TÜV Rheinland, where they did this failure mode event analysis, and it turned out that the most frequently occurring problem in PV systems was actually mismatched connectors. So you have one connector from one brand and another connector from another brand, and you put those together. And since they don't fit perfectly together, then quite quickly you would have moisture coming into the connectors and it would start to break down and the resistance would go up and you would have an arc fault and so on. Then later on, the guys from Solar Grade, it's a workflow app for the industry, you should check it out, it's great stuff. They started to actually document every time a technician is in the field, he does a service intervention, he logs the data on his app, and then very quickly you can see here on the bar diagram that what is actually sort of giving the problems in the field is field-made connectors and wire management. It's perfectly in alignment with the previous studies from TÜV Rheinland. So the number 1 electrical issue in power plants, solar power plants, tends to be cables, connectors, and that kind of thing. And then later on comes the isolation problems that follows from problems in this whole cable and connector story. 3, homogeneous long-term light absorber degradation. When it comes to actually discussing the solar cells themselves, we have something we refer to as potential induced degradation. That is probably the most well-known phenomena of homogeneous power output degradation. It's something that happens over time as the potential of the solar panels is tearing down this low-quality solar cells. I should immediately say that it's not all solar panels that will suffer from PID, potential induced degradation, but if they're not made in a correct way, they are actually sensitive to high voltages, especially when now we're starting to go to higher and higher voltages. So we see this homogeneous degradation in the power output. So the question that you would need to ask is, when there is a power loss in your PV system, is it really caused by a homogeneous degradation in the light absorbers, or could it be something else? That's the main advice I would urge you all to ask, instead of just assuming that it's something you can see by measuring the voltage or something you can see by, analyzing the current of a photovoltaic system. Try and check out the wire management first, because usually that's where the problem is. And then you also have other modes of degradation in PV system absorbers. And that's actually, it's like a topic in itself. It's a research topic to find out how is silicon or other semiconductors for that matter, how are they degrading over time? There are many different mechanisms that can cause this. But the point is that nowadays, most of them, they are quite stable. They will last for a long time if the PV panel construction is of good quality. Number 4, mechanical panel degradation, because you can have super cells, but if you don't have a good lamination, moisture is going to come in and then you're going to have some sort of fault, which is not a homogeneous degradation of the output power. It's going to be like an isolation fault. So the mechanical construction and quality of the panels is, in my opinion, or in my experience, I should say, it's on a 4th place of the most frequently occurring issues, because we see these problems with panels when they're not properly made. It's just they're not going to last as long. Also, the handling, sometimes people walk on the panels, they can't take that, the cells crack and so on. So definitely, when you're shopping for a big power plant, make sure that you have a thorough assessment of how those panels are actually made, what kind of materials they are sourced by or sourced from, and so on. Number 5, factors that are external to the PV system. As we move forward in the solar industry and install more and more solar power, we also have more and more things close to our solar power plants. If it's a residential PV system, we have trees and birds and rodents and leaves falling and all of those things. We know about that. But also, if you have a PV power plant close to, close to the water, you will have a very high saline content in your air around the PV system, so it's gonna corrode faster. Those would be like, that's on the 5th place of where you can see some electrical issues. It's very hard to say specifically what is the most commonly environmental or external factor, but definitely if you have a big PV system in a moist area, you're going to see a lot of ground faults, and there tends to be more rodents gnawing on the cables. So isolation faults is going to be something very important, especially on the northern hemisphere where you have a lot of moisture. You don't always have ideal weather. In that case, it's a mix of all these top 5 issues. So to just wrap up a bit, of course, all this material, you can find it on our website and go in depth with it. There's a lot of content. Also, each of these 5 issues is actually a topic for like a whole booklet or something like that, where you can go in depth and discuss all these things. But the most important one, I would say, when you're going to a new PV system, you don't know what is wrong, you just know that it's not producing the power it should. I would be immediately suspicious about the DC distribution faults in the cables and the connectors. Make sure it's not that. And then thing number 2, what about grounding? What about isolation faults? That's the second part. If that is okay with if there's no faults in the cables and connectors, there's no isolation faults, then I would start to think about what is the quality of the solar cells themselves. Is it a light absorber problem? If that is okay, then I would check the mechanical stability of the panels, and I would check the quality of installation itself. And then if you still can't find the problem, then it's probably an external factor. You might need to clean the panels, something like that. So that would be the top 5 based on what we see when we are corresponding with our customers and trying to figure out what is wrong at a specific site.